what we're trying to do. We're trying to figure out how can we use these side lengths to determine whether a triangle is acute, right, or obtuse. Okay, acute, right, or obtuse. Hold on 1 second. Okay, use the Pythagorean theorem and its converse to solve problems. Using the Pythagorean theorem inequalities to classify triangles. Pythagorean theorem hypotenuse is Pythagorean triple. Yes, Mr. Cardle. All right, so let's write this down first, though. Okay, you definitely need to write this. A squared plus b squared equals c squared. This is the Pythagorean theorem. That's all that you have to worry about writing down. Okay? It is probably the most, that's the formula. It's probably the most famous mathematical relationship. As a matter of fact, there's a lady that's doing some seminars for us here at the high school. And we go on our planning sometimes, we go meet with her, and she was like, I don't remember anything about geometry except the Pythagorean theorem. And she's older than us. I have 2 years. Several decades. Okay, so you know, it's kind of neat. Remember one of those things that you'll tell your grandkids one day. In a right triangle, the sum of the squares and lengths of the legs equals the square of the length of the hypotenuse. Awesome. Okay, doesn't really mean too much if you can't figure this out. Let's make sure we're understanding this. The easiest way to understand the Pythagorean theorem is to know what your A, B, and C are. Okay? A, B, and C. When I see this formula, I kind of cringe as a math teacher because this is really how I want you to remember it. Leg squared plus leg squared equals I caught. I caught in, yeah, Hindu's squared. Right? Leg squared plus leg squared equals hypotenuse squared. We get into this habit of saying, okay, a squared, b squared, c squared, and then we get on a problem and they change the variables on me, x, y, and z, and I get these questions all the time. Which one's my hypotenuse? Which ones are my legs? How do I know where to put z and y and x in this problem? Well, I see why that's an issue, okay? Because we only teach you a squared plus b squared and c squared. So the bigger principle that you need to know is this. I start in my right angle and go opposite of it. This is my hypotenuse. You ready there? If I start in the right angle and go opposite of the right angle, that's my hypotenuse. The longest side is the hypotenuse. Absolutely. Okay. Sometimes though, you really look at a triangle and tell the difference between 5 and 4. It's tough. No, I like your magic, but maybe not. Okay. The non-hypotenuse sides are considered legs. The reason I like that is it's foolproof. It'll work if I flip this triangle around any way you want to. If you do that method, you'll be okay. All right? You'll be okay. Leg squared plus leg squared equals hypotenuse squared. All right. I'm going to go flying through some of these examples. Okay? Check it out and ask yourself this. You don't have to write it down. Which one of these sides is the hypotenuse? X. Okay? Which means when I put this into my Pythagorean theorem, 2 squared plus 6 squared equals x squared. Right? Leg squared plus 2 is 4, 6 and 6 is 36. Together they add to have a sum of 40. How do I get rid of this power of 2? Take the square root from both sides. If I take the square root from both sides, I get the square root of 40. Right? I'll tell you later in the day how I want you to simplify that. Sometimes we're going to put it in simplified radical form. Sometimes we'll put it in decimal place. That's the answer. This is the simplified radical form of the answer. Okay? Ooh, here's the tougher one. What side is my hypotenuse? What sides are my legs? Okay, so look what I have to do now. X minus 2 squared plus 4 squared equals x squared. Oh, shucks. What do I have to do, DJ? Don't forget this part right here, guys. This is all last year's work. X minus 2 times x minus 2. Quadratic expression. You can't escape them. Got it? X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 4x. Negative 2 times negative 2 is 4. Okay. 4 squared is 16. X squared stays by itself. What they did here was they subtracted x squared from both sides. They combined these two terms. Negative 4x plus 20 is 0. Added 4x to both sides. Divided both sides by 4. And got x equals 5. Tough, right? There's a lot of properties in there. EOC is all over this question. You hear me? You got to remember how to distribute, and then you got to be able to solve too. Take your time. There's so many mistakes on constructive responses. You're going to take time, right? Got me? Good. Constructive responses. This is part of my answer. Constructive responses is this. Something like this. Okay. You know what I was getting a lot of? Getting a lot of this. And somehow this magically became free. I'm still trying to figure out how that became free. Doesn't matter. Yeah, there's a few different ways you can do it. My point is this. This is a simple algebraic expression. Y minus 2y is not 3y. Negative 1y. Right? It's negative 1y. You see that? Some people forget to change the sign. Well, time to remember. It's time to remember if there ever was a time. All right, what is the hypotenuse here? X plus 4. Same thing. I'll see what we're going to get into today, right? Same setup. You got to identify the hypotenuse, you got to identify the legs, and then you got to simplify the expression. I think that's going to be the harder part of today's lesson, unless I'm mistaken. Okay? Yes. I'm going to create equal to x. Here, the step from here to here was to combine like terms. Okay, so they subtracted x squared from both sides and subtracted 16 from both sides. And then the step from here to here was divide both sides by 8. Okay, go ahead and write this down. I don't think you'll have to memorize it, but I want you to write it down. A set of 3 non-zero whole numbers, A, B, and C, such that a squared plus b squared equals c squared. We call that a Pythagorean triple. Example, 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Hey, write down a couple of those examples so you'll remember. Correct. All right. Non-zero means other than zero, correct? A zero whole number could include zero. So non-zero means zero is not included for A, B, or C. Whole number. What are whole numbers? Say what? Okay. Anything that's not check it out. Decimal, fraction, or radical. Whole numbers, the easiest way to remember them, counting numbers. Oh, what do you people okay. Okay, got me? We don't typically, when we count, say 1, 2, 3, 4, 3 times square is 6, right? That's typically not what we do. Okay, but another thing you got to think of here, when we're talking about sides of a triangle, have you ever seen a triangle that has a negative side length? Good, because they don't exist. Okay? So are we going to ever have negative numbers in here? No. It's geometrically impossible to have a negative side length. Right? Got me? But we're taking absolute value. Never going to have a negative number. I want y'all to figure this one out. Okay? Write down this example. Take a couple minutes. Determine, look at the question now. Tell if the side length form a Pythagorean triple. Tell me if this ends up being a Pythagorean triple. Okay? Okay. Guys, first off, you got to get this process down. What side am I looking for in this triangle? The hypotenuse. Got to identify the hypotenuse. Always start by identifying what side is the hypotenuse. Say it again. Start off each of these problems by identifying the hypotenuse. The hypotenuse is opposite the right angle. We'll label it X. Now I can plug in my formula. Leg squared plus leg squared equals hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. DJ, what's 14 times 14? 196. Somebody tell me what 48 squared is. What? 2304. Okay. 196 plus 2304 is 2500. How do I get rid of that power of 2? Okay. Put it in a radical. And when I put that in a radical, what I'm doing is taking the square root. Again, there's two main hiccups on these problems. Not identifying the hypotenuse and not understanding how to get rid of this power of 2. Take the square root of both sides and you will do that. What's the square root of 2500? Go back to your definition of Pythagorean triple. It's 14, 48, and 50 non-zero whole numbers. So are these a Pythagorean triple? Yes. Because 14, 48, and 50 are non-zero whole numbers. This is a Pythagorean Got me? That's all we're asking right now. Any questions on that? I got it. All right. Don't worry. Please don't worry about writing this down. But look up here, okay? All right. The converse of the Pythagorean theorem gives a way to tell if a triangle is a right triangle when you know the side lengths. If the sum of the squares of the length of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. Basically, that's what, here's what this means, okay? If I know the values for A, B, and C, and if A squared plus B squared equals C squared, then I know that I've got a right triangle, okay? In other words, in every single right triangle, every single right triangle, every single right triangle, A squared plus B squared has to equal C squared. Every single right triangle, A squared plus B squared equals C squared. Not in some, not in those, not in almost all of them. Every single right triangle, leg squared plus leg squared equals hypotenuse squared. Maybe it's equal lengths of sides. Leg squared plus leg squared equals hypotenuse squared. So there's two things that I absolutely know about triangles. The interior angle always add up to be 180 degrees. And in every single right triangle, leg squared plus leg squared equals hypotenuse squared. We don't have too many absolutes in this class, right? Not too many times that I say this is always true. A lot of times it depends. Those two things are absolutely always true. Always the case. No exception. Right? If you come across a right triangle that doesn't fit this particular theorem, it's not a right triangle. Something is wrong. So, what happens if I don't have that particular formula? This is the part that is the added portion for today. You probably want to write this down. This is our Pythagorean inequality theorem. Here's what it says. If C squared is greater than A squared plus B squared, ABC is an obtuse triangle. And if C squared is less than A squared plus B squared, ABC is an acute triangle. In our warm-up problem at the beginning of class, I gave you, I don't remember what the side lengths were, 5, 6, and 12. Is that right? Yeah, 6, 7, and 12. And 6 squared plus 7 squared was less than 12 squared. 144 is greater than 85, which means I've got what kind of triangle, guys? If they were flipped, if the legs, the sum of the squared values of the legs is greater than the hypotenuse squared, I've got an acute triangle. What if they're equal? Yes, I have a right triangle. Okay? It's actually not that bad. It's the first time thinking of it this way, so it's kind of fuzzy right now. But you can classify triangles just based on that information. You can look at the lengths of the triangle, determine A squared, B squared, C squared, and that will give you the information. Right? right, just bear with me here, okay? What does it mean? What does it mean for a triangle to be called a right triangle? As a right angle. So if the Pythagorean theorem is true, I know it's a right triangle. If it's a right triangle, there has to be a right angle, right? If my hypotenuse, which it wouldn't be hypotenuse, okay? If the longest side is greater than the sum of, let me say it correctly, if the square of the longest side is greater than the square of the sum of the other two sides, okay, then yeah, it's an obtuse triangle, which means that one of these angle measurements has to be greater than 90. What's the definition of obtuse? 91 and 179 degrees, correct? All I got to remember. If the opposite is true, if the longest side, the square of the longest side of the triangle is less than the sum of the squares of the other two legs, it's an acute triangle. In an acute triangle, how many acute angles do I have? 3, which means that these 3 angles all have to be less than 90 degrees. A lot of information there, a lot of definition. Okay? I was going to have you do this. I think I'm going to punt on it for now and take it right into the classwork. But